Imagine uncovering evidence of a solar storm so powerful that it could have altered the course of history, hidden within the rings of an ancient tree. This isn't science fiction. It's a groundbreaking discovery that has scientists rethinking how vulnerable our modern world truly is to the forces of the cosmos. And this is where things get fascinating. What if the same natural phenomenon that once lit up the skies with dazzling auroras could now cripple the very technology we depend on? To understand this better, let's dive into the science behind solar storms. These cosmic events occur when magnetic fields on the sun twist and snap due to its rotation, unleashing enormous bursts of energy into space. While Earth's atmosphere shields us from direct harm, these storms manifest in ways we can observe, like the breathtaking northern and southern lights, or, less pleasantly, through disruptions like power outages or satellite malfunctions. But some solar storms are far more intense than others. Known as Miyake events, these rare occurrences unleash cosmic radiation levels approximately 20 times higher than typical solar activity. First identified by Fusa Miyake in 2012 during her doctoral research at Nagoya University, these extreme storms have only been documented 6 times throughout recorded history. Recently, researchers at the University of Arizona made significant strides in understanding one such event. By analyzing tree rings, they pinpointed a Miyake event that took place between 664 and 663 BC. Their findings were published in the journal Communications Earth Environment. This meticulous work not only helps refine models predicting solar behavior, but also underscores the importance of preparing for potential future catastrophes. Lead researcher Irina Ponyushkina explained to the University of Arizona News, the energy released during these events doesn't just alter the radiocarbon content of the atmosphere, it reshapes its chemistry entirely. But how exactly do scientists use trees to date these ancient solar storms? The secret lies in carbon-14, a radioactive isotope formed when cosmic rays interact with nitrogen in the atmosphere. As trees grow, they absorb carbon, including carbon-14, into their rings. By examining the concentration of radiocarbon in these rings, researchers can identify spikes corresponding to solar storms. To corroborate their findings, the team compared tree ring data with ice core samples from polar regions, which contain elevated levels of beryllium-10 during periods of heightened solar activity. According to Ponyushkina, if both poles show a simultaneous spike in beryllium-10 alongside increased radiocarbon in tree rings, it confirms the occurrence of a solar storm. Now here's the part most people miss. While humanity has survived countless solar storms without issue, including Miyake events, our dependence on advanced technology makes us uniquely vulnerable today. Consider the Carrington event of 1859, a relatively moderate solar storm that wreaked havoc on telegraph systems worldwide. Telegraph operators reported sparks flying from their equipment, injuring workers, and even starting fires. If something similar happened today, the consequences would be exponentially worse. A modern-day Miyake event could spell disaster for global infrastructure. Satellites might fail en masse, rendering GPS navigation useless. Power grids could collapse, plunging entire cities into darkness. Computers and communication networks might suffer irreparable damage, potentially costing trillions of dollars in economic losses. Dendrochronologist Charlotte Pearson of the University of Arizona told the BBC, people thousands of years ago might have marveled at the auroras caused by these storms, but beyond that, their lives wouldn't have been affected. We're the first society on Earth that faces serious risks from such an event. So, what does this mean for us moving forward? Should governments and tech companies prioritize safeguarding critical systems against solar storms? Or should we accept the risk, hoping that such an event won't happen anytime soon? These questions aren't just theoretical. They demand urgent attention. After all, the next Miyake event could strike tomorrow or centuries from now. What steps do you think we should take to protect ourselves? Share your thoughts in the comments below.